In this video, we are going to solve paper 6-1, May-June 2020. Question number 1. A student investigated the dyes contained in different colored inks using chromatography. Water was the solvent. The diagram shows how the student set up the apparatus. Here we can see the chromatography paper, and this is water and baseline drawn in ink. Identify two errors in the way the student set up the apparatus. Here we find the mistake as baseline is drawn in ink and the level of the solvent is above the baseline. Question B. The student then carried out the chromatography correctly. The diagram shows the results. Which ink contains the greatest number of soluble dyes? You have to check each color. Orange is having 2 spots, yellow is having only 1 spot, green is having 2 spots. So you can see the black is having 3 spots, so black is the answer because it is giving you the greatest number of soluble dyes. So the answer is black color. Question number 2. Which two inks are made of single soluble dye? To recognize single soluble dye, you have to find out that which color is giving only 1 spot. Here we can see that blue and yellow are giving you only 1 spot. That's why they will have only single soluble dye. Yellow and blue spot. Question number 3. From chromatogram, it is not possible to tell if the red ink contains different dyes. Suggest how experiment could be changed to find out if the red ink contains different dyes. Here we can see that the red dye has not even moved and it did not give any spot. It means that it is insoluble in water, so we have to change the solvent for this one. So the answer is by using different solvent. Question number 2. A student investigated the reaction between dilute hydrochloric acid and two different aqueous solutions of sodium carbonate, solution E and F. So the experiment is between dilute HCl and the sodium carbonate is of different concentration. 3 experiments were done. Experiment 1. A burette was filled 0.0 cubic centimeter mark with dilute HCl. Using a measuring cylinder, 25 cubic centimeters of solution E was poured into conical flask. 5 drops of thermophthalein indicator were added to conical flask. Dilute hydrochloric acid was slowly added from burette to the conical flask while the flask was swirled until the solution just changed color. Use the burette diagrams to complete the table for experiment 1. This is the titration experiment. We have to read the lower meniscus for the burette reading. We can read and you can see it is at 0 and final burette reading is 10.2 here, and here we will give the difference of these two reading. Final burette reading is written 10.2, initial burette reading is 0.0 and the difference is 10.2. Experiment 2. The conical flask was emptied and rinsed with distilled water. The burette was refilled with dilute HCl. Experiment 1 was repeated using 5 drops of methyl orange indicator instead of thymophthalein indicator. Use the burette diagram to complete the table for experiment 2. Final burette reading is written 25.9 and initial burette reading is 5.5, and the volume of HCl is used by difference 20.4 cubic centimeters. In this experiment, we can check that they have only changed the indicator, and by changing the indicator, the volume of HCl used is with thymophthalein 10.2 cubic centimeter of HCl was used, but by changing indicator as methyl orange, now double volume of HCl is used. Experiment number 3. The conical flask was emptied and rinsed with distilled water. The burette was refilled with dilute hydrochloric acid. Using a measuring cylinder, 25 cubic centimeters of solution F was poured into conical flask. 5 drops of methyl orange indicator were added to the conical flask. Dilute hydrochloric acid was slowly added from the burette to the conical flask while the flask was swirled until the solution just changed color. Use the burette diagrams to complete the table for experiment 3. Here, burette reading is showing final reading as 33 cubic centimeters and 2.4 as initial burette reading, and the difference is 30.6 cubic centimeters. What color change was observed in the conical flask in experiment 2? To answer such questions of color change, first of all you have to check which indicator has been used in experiment, and then you have to recall the colors in alkaline medium and acidic medium. Here we can see that indicator methyl orange, which is used as indicator, and as we know the color change of methyl orange. In alkaline medium, methyl orange is yellow and it changes to orange or red in the and when it is neutralized, it is changing back to orange. So the color change is yellow to orange or red. Compare the volume of dilute hydrochloric acid in experiment 2 and 3. Explain any difference. We have to check that how much volume of HCl is used in each experiment. We can read the reading here. So experiment 2 and experiment 3. In experiment 2 it is 20.4 and in experiment 3 it is 30.6. So if you divide 30.6 divide by 20.4, you will get the value that how much times it is used. Compare the volumes of dilute hydrochloric acid added in experiment 2 and experiment 3. Explain any difference. We know that in experiment 2 solution E was used, in experiment 3 solution F was used, and for solution F it needed more volume of HCl to neutralize it. 30.6 volume of HCl was utilized to neutralize solution F, and so the comparison is telling that solution F is 1.5 times more concentrated than solution E. So in experiment 3, 1.5x more volume of HCl is added. This is the comparison. If large volume of solution from burette is required to neutralize, it means that the solution in the flask is more concentrated. Question D. Determine the simplest whole number ratio of volumes of dilute HCl used in experiment 1 and 2. In experiment 1, it used 10.2 cubic centimeters of hydrochloric acid. In experiment 2, it used 20.4 cubic centimeters of hydrochloric acid. So the ratio is 1:2. Question number E. What volume of dilute HCl would be required if experiment 3 was repeated using thermophthalene indicator instead of methyl orange indicator? Now this question will take help from the first experiment. We knew before thermophthalene used half volume of acid. So here we have to use the same comparison because we are repeating the indicator thermophthalene again in experiment 3. We are repeating experiment 3 with thermophthalene instead of methyl orange indicator. So experiment 3 normally used 30.6 cubic centimeters. So we will use the half volume of experiment 3 because it is now using thermophthalene which requires the half volume of HCl. Question number F. The conical flask was rinsed with distilled water between each experiment. Why was the conical flask rinsed? To remove residues from previous experiment. Question number 2. Why does it not matter if a little distilled water is left in the flask after it has been rinsed? The answer is because it does not change the volume of solution E or F, because the volume is already measured. This is a common question in paper 6. They usually ask sources of error and improvement for that. So source of error 1, as we know that they used measuring cylinder, so better to use pipette because it gives more accurate volume. And second error, the experiment is done only once, so it should be repeated and then mean or average should be taken. Question number 3 is from test of ions. Two solids G and H were analyzed. Tests were done on each solid. Test on solid G, complete the expected observations. Solid G was placed in a boiling tube. Excess of dilute sulfuric acid was added to the boiling tube. Any gas produced was tested. We know that it contains carbonate, and when we add acid to the carbonate, it gives carbon dioxide gas. So the observations will be effervescence or bubbles, and they say also it was tested. So also give the test observations that it turned lime water milky. Question number B. Identify the gas produced in A. It was carbon dioxide gas. Number C. Aqueous ammonia was added slowly until in access to solution produced in A. And observation. Here you have to give the results of ammonia solution with copper ion. We know it gives blue precipitate and in excess ammonia solution, precipitate dissolves and gives dark blue solution. Test on solid H. Tests were done and the following observations were made. Solid H. So the first test is flame test and it gave yellow flame, so it will be sodium ion. Test 2 is it was placed in boiling tube and it was heated strongly. It gave condensation near the mouth of the boiling tube, so it must be hydrated salt. That's why it is giving water droplets. Solid H was dissolved in distilled water and it was divided into 2 equal portions. Test 3 was done. It added and they added 1 cubic centimeters of dilute nitric acid followed by silver nitrate, aqueous silver nitrate. We know this is halide test and specifically done for halides. And if it is not giving any results, because you can see that there is no change, it means there is no halide. Test 4 is 1 cubic centimeters of dilute nitric acid followed by a few drops of aqueous barium nitrate. It is specifically test for sulfate ion were added to the second portion of solution. It gives white precipitate, so it means sulfate ion is present. What conclusion can be made from result of test 3? It is indicating that halide ion is absent. Question E, what conclusions can be made about solid H from results of test 1, 2 and 4? So we found out that it is hydrated sodium sulfate. The last question is about designing an experiment. Cobalt, manganese and nickel are metals. They react with dilute hydrochloric acid to form hydrogen gas. Plan an investigation to find the order of reactivity of these three metals. You are provided with samples of each metal, dilute hydrochloric acid and common laboratory apparatus. Your plan must make it clear how your investigation will be a fair test and how you will use your results to place the metals in order of reactivity. We need to explain the experiment here and then conclusion. So here, take equal mass of each metal measured by balance, equal mass to make sure the fair test. Number 2, take 50 cubic centimeters or any volume of dilute HCl using measuring cylinder into conical flask using same concentration for each experiment and at same temperature. You must mention the conditions must be kept same to maintain the fair test. Place rubber band and connect to the gas syringe. Add solid to the flask. Start the timer while adding solid to the acid and measure the volume of gas collected after 60 seconds. Repeat the same experiment for other metals, keeping the conditions same. Maximum volume of gas collected in 60 seconds shows the most reactive metal. This experiment can be explained in other way. You can observe any other factor like change in temperature or time taken for metal to dissolve. Yani change in temperature, yani how quickly the temperature changes. For the most reactive metal, it will be more quick. Or the time taken for metal to dissolve. If it is more reactive metal, for more reactive metal, it will take very short time to dissolve the metal. Or volume of gas produced. You have to check how quickly the volume of gas it is largest for the most reactive metal in a given time. So these factors can be observed. You can pick up any factor, keep other conditions constant, and then you can repeat experiment for each metal.